Bismillahirrahmanirrahim. Dear cadet, Assalamu alaikum. Today we start the new chapter, chapter 3, variations. So the first topic we will discuss, that is ratio. So for exercise 3.1 we have three topics: ratio, proportion and variation. So first thing is ratio. What do you mean by ratio? Comparison of two quantities with the same kind and with the same unit, or any two quantities of the same kind and the same unit, the comparison between them is called a ratio. So the ratio of two quantities A and B is denoted by A ratio B. These two dots denoted by, this denotes the ratio, and is defined as A ratio B is equal to A divided by B, or we can write A by B, where B does not equal to 0. That is, denominator cannot equal to 0 because division by 0 is not allowed. So the comparison of two quantities of the same kind, of the same unit, that is called ratio. For example, example 1, write 3 ratio 12 in simplest form. 3 and 12 may be the ages of two persons, or the amount with two persons, having two persons, or the height of two persons. So the ratio or the comparison between same quantities. For example, a person has rupees 3 and B has 12 as pocket money. So we compare these two. So such like of comparison between the amount with them, or the height between two persons, or the length of the height of two persons, or the amount with them, etc. So 3 ratio 12, we write this in the form 3 double dot 12. Double dot shows ratio, 3 ratio 12. So simplification of ratio means we divide both the terms, both the elements, on both the side if there is anything common. So in 3 and 12 there is 3 common, so we divide both the ratio by 3. So 3 divided by 3 we get 1, 12 divided by 3 we get 4. So 1 ratio 4 is the simplest form of 3 ratio 12. So thus if we multiply any ratio, so we will multiply the same term to both sides. For example, we multiply the simplest form by 3. So this means we multiply 3 by 1, multiply 3 by 4. Again we get 3 ratio 12. Similar example 2. 6a ratio 18b in simplest form. Write this one. So 6a ratio 18b. There is 6 common in both the ratios. So first of all, divide both the ratio, both the side by 6. Dividing 6a by 6, we get a ratio. 18b by 6. So 6 3 the 18, 3b. There is nothing common. So a ratio 3b is the simplest form of 6a ratio 18b. Next is proportion. The proportion means the equality, simplest definition. The equality of two ratios is called proportion. In ratio there are two elements, comparison of two elements. But in proportion we take two ratios. For example, we have the comparison between two persons, their ages. First comparison between their ages. Person A has the age of person A is 14 years, the age of person B is 18 years. This is one ratio. Now the amount with person A, that is rupees 20, the amount with person B is 40. So that is, we get another ratio of the same kind. So similarly, the equality or the comparison of two ratio, that is called proportion. Therefore in proportion there are 4 elements. For example, if 4 quantities A, B, C, D are in proportion, then mathematically these are written as A ratio B proportion C ratio D. So in proportion, instead of proportion, we write is equal to. We can write this in the form A ratio B is equal to C ratio D, because by definition the comparison or the equality of two ratios. So one ratio is A ratio B, it may be between ages of two persons. C ratio D, that may be the amount with having two persons. So two different ratios. So there are two ratios. So the equality of two ratios, that is called proportion. So therefore in proportion we have four elements. A ratio B, proportion C ratio D. So A, B, C, D are four elements. The middle one, these are called means, and the first and last, these are called extremes. So we have a formula. We can solve any proportion, any problem of proportion by this form. Product of means is equal to product of extreme, or product of extreme is equal to product of mean. When there is any element missing or unknown, for example, in proportion we have four elements, but if three are given, we can find the next one. It may be the first is missing, second is missing, third is missing, fourth is missing. So we apply the formula product of mean is equal to product of extreme. Thus we find any element, first, second, third, fourth. Any one of them may be missing. Or we can write this product of extreme, product of mean, product of extreme A multiplied by D is equal to B multiplied by C. A multiplied by D, B multiplied by C. So ADR extreme is equal to product of mean. Thus, by this relation, we can solve any proportion, or we can find any element which are missing in the given proportion. Or we can write this in the form A ratio B, A over this ratio, A ratio B, A divided by B is equal to C ratio D, C divided by D. Or in this form, A over A divided by C is equal to B divided by D. So first in this form, second in this form. We can write in these four forms proportion. So these are the properties. For property, we can write a proportion in this form. Now the problems on proportion and ratio. Let example 3. If a cube minus b cube, a square minus b square, a square plus ab plus b square, and x are in proportion, and there are four terms, four elements, they are in proportion. Find the value of x. X is unknown. How we can find? So first of all, we write all the four elements in the proportion. A cube minus b cube ratio a square minus b square is equal to a square plus ab plus b square ratio x. Now we have four elements. Product of extreme is equal to product of mean. So product of mean a square minus b square multiplied by a square plus ab plus b square is equal to product of extreme x multiplied by the first term, first and last. So x into a cube minus b cube. Thus we are going to find x. So divide both the side of this equation by a cube minus b cube. We get x is equal to this one, a square minus b square into a square plus ab plus b square divided by a cube minus b cube. Now expanding these form, we can get the value of x. We can write x is equal to, factorizing first term, a square minus b square, we can write a minus b into a plus b into this factor a square plus ab plus b square, divide by factorization of a cube minus b cube. So we have two factor a minus b into a square plus ab plus b square. So this factor cancel with a square plus ab plus b square, and a minus b factor cancel with a minus b. We get only a plus b. Thus x is equal to a plus b. We can find the value of unknown in the given proportion. Next use of ratio exercise. Come to exercise 3.1. Which is the greatest ratio? 5 ratio 7 or 151 ratio 208. Two ratios are given. So it is difficult to find which one is greater between these two ratios. So there is a method. Equate the denominator of both the ratios. Equating and we are going to transform the denominator in the same number. For example, 5 divided by 7, we can write this in the form 5 ratio 7, 5 by 7, and 151 ratio 208, we can write 151 divided by 208. So in denominator there is 7 and 208. So multiply and divide 5 by, now we take the first ratio, 5 by 7 is equal to 5 by 7, multiply and divide by 208, because 7 is present, and we multiply both the denominator 7 and 208. So by 7 and 208 we multiply again 208 with the numerator. They will cancel, again we get 5 by 7. So from this we get 5 into 208, 104, 1040, divided by 7 into 208, 1456. Again next ratio we can write 151 ratio 208. We can write in the form 1 over 51 over 208, or 151 over 208, multiply and divide by 7 to get the same, because in the first ratio we get 7 multiplied by 208. So here 208 is present, so we multiply and divide by 7 to get again in the denominator 208 multiplied by 7. Thus we get the same number. So by multiplying this ratio, 151 into 7 we get 1057, and 208 into 7, 1456. So now in both the ratios 1456 denominators are equal. When the denominators are equal, this means 1040 out of this one 1456 and 1057 out of 1456. So compare only the numerator. So in numerator there is 1040 and 1057. So obviously 1057 is greater than 1040. So when the denominator, because denominator are same, so which the numerator is greater, 1057 is greater. This means in both the ratio we say that 1057 is greater than 1040. So this means if numerator of the second ratio is greater, this means second ratio is greater. 151 ratio 208 is greater than the first ratio 5 ratio 7. Now question 2. Gold and silver are mixed in the ratio 7 ratio 4. If 36 grams of silver are used, how much gold is used? So first of all, how much gold is used? We have to find gold. So let the amount of gold is equal to x, that is unknown. Amount of silver used, that is 36 grams. And the ratio given ratio is 7 ratio 4. This means ratio using proportion. First gold ratio silver ratio is given 7 ratio 4 is equal to, again gold is unknown, x ratio silver is given, that is 36 grams, x ratio 36. So we get a proportion. Now product of extreme, product of mean. By using that formula we can product of mean, 4 multiplied by x, that is 4x is equal to 36 multiplied by 7. First element, last element, product of extreme. So divide both sides this equation by 4. Dividing by 4 we get x is equal to 36 into 7 divided by 4. 4 9s are 36 and 9 7s are 63. So x is 63 mean amount of gold, that is 63 grams. So using ratio and proportion we can find daily problems by this method, by taking the ratios. Question number 3. Second use of ratio. Divide the annual profit of rupees 40,000 of a factory among 3 partners in the ratio 5 ratio 8 ratio 12. If ratio between the 3 partners is given, on which the profit will be divided. So first of all, given ratio of 3 partners, that is 5 ratio 8 ratio 12. So we will find the sum of ratio. That is 5 plus 8 plus 12, total 25. Now total amount is 40,000 to be divided among three partners. So share of the first partner gets 5 out of total 25. So multiply by 40,000. How much in 40,000? Simplifying this one, 5 5 are 25, 5 8 are 40, or and 3 0. Now 8,000 and 5 cancel again with 5. So share of first partner is 8,000. Similarly, share of second partner, mistakenly it is written as first. Make it change it as second partner in this third partner. So share of second partner gets 8 out of 25. So we write 8 divided by 25 multiply by out of 40,000. Simplify this one, second partner gets 12,800. Similarly, share of third partner, that is third partner is getting 12 out of 25. How much in 40,000? Simplifying this one, that is rupees 19,200. So by adding these three share of three partner, 8,000, 12,000, 800 and 19,000, 2,000, we get the total 40,000 amount to be divided among the three partners, first, second, third. So that is the second use of ratio proportion in daily life. Now come to question 4. If 11 ratio x minus 1 is equal to 22 ratio 27, find the value of x. X is unknown. All the four elements of a proportion are given. So by using properties of proportion, product of extreme, product of mean, given ratio is this one, using formula product of mean is equal to product of extreme. Product of mean middle terms are x minus 1 and 22. 22 into x minus 1 is equal to product of extreme, 11 multiplied by 27. Again, that is 22. Now we are getting this simplified, we are writing them in simplified form. Divide both sides by, here 11 is written, that is mistakenly, we will divide this by 22. Divide both sides by 22, that is this one, both sides is divided by 11. Okay, so 11 cancel with 2, we write 2 into x minus 1 and 11 cancel, is equal to 27. Similarly, now simplifying the brackets, 2x multiplied by minus 2 minus 1, that is minus 2, is equal to 27. 2x is equal to 27 plus 2, transforming minus 2 to right side. So 2x become 29, dividing both sides by 2, we get 29 by 2 are 14.5. Thus value of x is equal to, unknown x is equal to 14.5. So here we can directly divide both sides by 22 and simplifying r, for simplification of 11, we divide first of all both sides by 11 to cancel 11 with 11 and 11 twos are. So again we get this simplified form. Now simplifying this one, we get the value of x. Next topic is variations. So there are two types of variations, direct variation, inverse variation. So direct variation, always there is some relation between two quantities. So if the relation is such that the increase in one quantity causes increase in the other quantity, that is called direct variation, or decrease in one quantity cause decrease in the other quantity, that is called direct variation. If two, for example, if two quantities x and y vary directly, then we write them as y is proportional to x, or y is directly proportional to x. That is symbol of proportion. So we can simplify this or change this in equation form. y is equal to kx, where k is the constant of proportion. Because if we comparing any two quantities, there is always some constant ratio between them. If we are taking, we are going to compare two things. So the comparison of two things mean division, or so by division we mean there is some ratio, there is some number which is constant between any two ratios. So y is equal to kx, where k is constant of variation. For example, the ratio between 2 divided by 4. So 2 cancel with 4, we get 1 by 2. Similarly, if we double the quantity 4 by 8, so again 4 1 the 4, 4 to the 8, we have 1 by 2. Again, if we triple the quantity, so that is 12 divided by 28, again 24, cancel, again we get 1 over 2 ratio, 1 by 2 constant. So that 1 by 2 between any two ratios, we can double them, we can simplify them, or increase them or decrease them. There will be one number constant, that is called constant of proportion or constant of variation, which is we denoted by k, and generally y is directly proportional to x. The sign of proportionality change into equality by putting the constant. There is, we can write in k is equal to, if we divide this by x, so k is equal to y by x, we can write. So y by x mean ratio between these two relations, these two elements. K is equal to y by x, division between these two, we are comparing y and x is equal to k. So this means there is some constant ratio between y and x which we are dividing. So that is why k is called constant of variation or constant of proportion. For example, come to question 5. There is direct variation between x square and y. So we write first of all y is directly proportional to x square, implies y is equal to kx square, constant of proportion. Now first of all we find the value of k, constant of proportion. Now in the question, look at when x is 7 and y is 49. So putting these two values, y 49, x 7, put in equation 1. So 49 is equal to k into 7x square. 7 square, again 49, k is equal to 49. Divide both sides by 49, we get k is equal to 1. That is constant of proportion. Once we get the constant of proportion, then we can find the value of x or y, which one is required. So now the question is, find y, that is, now we have to find y. Y is unknown. When x is 9, by using x is equal to 9, k is constant of proportion 1. So putting the value of k and x in the given relation, y is equal to kx square, y is equal to k1, and x is equal to 9 square. That become is equal to 1 into 9 square, 81. Y is equal to 81. We can find the other value. 1 is given at the end. One value is find y when x is 9. One value is given, we have to find the other by using constant of proportion. Next, inverse variation, two types of variation. So inverse variation simply we can define as when there is some relation between two quantities such that an increase in one quantity causes decrease in the other, or decrease in one quantity causes increase in the other quantity. So that relation is called inverse variation. We write inverse variation is if two quantities x and y vary inversely, then we write y is proportional to 1 by x square. Direct proportion means 1 is directly proportional to x. Inverse proportion means y is indirectly or inversely proportional to 1 by x, that is 1 by. Or we can write y is equal to k by x, where k is constant of variation. Again, case explained in the first question. K is constant of variation. So y is equal to K by x we get. For example, question 6. X varies inversely as y. So we can write y is proportional to 1 by x. Or change this into equality. We write this as y is equal to K by x, equation 1. Now, and when x is 4, y 24, putting x4, y24 in this value, we can get the value of constant of proportion or the value of k. So when x4, y24 put in 1, we get y24 is equal to k by 4. By cross multiplication, we get k is equal to 24 multiplied by 4, or k is equal to 96. Constant of proportion is 96. Now the question is, find y. We have to find y when x is 12 using k is equal to 96. So putting these value of x and k in relation 1, y is equal to k value is 96 and x value is 12. 12 adds are 96, we get value of y. So similarly we can find any value, one value is given using constant of proportion, value of constant of proportion, we can get the other values by substituting the first one. Either it may be x value or y value. If y value is given, we can find value of x, or x will be given, we can find the value of y. Next, question 7, part 1. R is proportional to 1 over p cube, and p is equal to 9, r is equal to 2. First of all, we write r is proportional to 1 by p cube. Change it into equality form. We can write r is equal to k by p cube, equation 1. Putting these two values, p9, r2, in equation 1. So 2 is equal to k by p value 9, 9 cube. Rk is equal to, we can write k 2 multiplied by 9 cube. Rk is equal to 2 multiplied 9 cube means 729. 9 multiplied by 9 multiplied by 9 3 times. So k is equal to 1458. Now to find r, when p is 3, using k is equal to, k value already known. When p is 3, value of p is given, we have to find r. So by first relation, r is equal to k by p cube. Putting value of k and p in equation 1, we get the value of r. R is equal to 1458. K divided by p. Value of p is 3. That is 3 cube. R 1458 divided by 27. So dividing this by 27, we get 54. Thus, our value of r is 54. Next, the last question, 8. If y is proportional to x, then complete the following tables. In the table, value of x are 4, 6, here is missing, and 15. Value of y 2, missing, 3.5 and missing. So first of all, we write the relation y is proportional to x. Change this into equality. That is y is equal to kx, equation 1. Now, when there are two values in the table, either it may be first, second, third, fourth column, in which column when two values are given, first of all we put these two values, x, value of x and 2 in the relation 1 to get the value of constant of proportion. So x4, y2, put y2, x4 in equation 1. We get 2 is equal to k into value of x4. Or 4k is equal to 2, divide both sides by 4. We get k is equal to 1 by 2. That is constant of proportion. Once we get value of constant of proportion or value of k, now we can put in either relation to find the other values. Now in the next column, value of x is given, we have to find value of y. So write this mathematically. X is 6, or we can write in second column, when x, we find x, Find y. Y is unknown and x is equal to 6 in second column. Using k is equal to 1 by 2. Put these values in 1. So y is equal to 1 is this one. Y is equal to k value 1 by 2 and x value 6. 2 3 is 6. We get y value is 3. So here value of y is 3. We write the table in the last where the values are missing. So the way we get the value x was given, we get the value of y, that is 3. In the third column, value of x is missing, that is unknown. So we write x is unknown, value of y is 3.5 and k is equal to 1 by 2. Again put in 1. By putting in 1, 1 is y is equal to, that is 3.5 is equal to 1 over 2 and x. First of all, to remove 2, multiply both sides by 2. So we get 3.5 into 2 is equal to x, or x is equal to 7. 3.5 multiplied by 2, we get 7. Thus, in the third column, value of x was missing, so we get x7. So here 7 we write missing value 7. Thus the table is completed. In the last column, value of x is 15, that is, and value of y we have to we have to find. So value of y, that is unknown. Value of x 15. Using k is equal to 1 by 2, put in equation 1. By putting in 1, y is equal to value of k 1 by 2, value of x 15. So again dividing by 2, we get 15 divided by 2, 7.5. Thus we get the value of y in the last column, value of y we write. So here table is completed by writing the value of y 7.5. Thus the table is completed. So we see, if we look at the table, in the first column both the values are given. It may be in the second column, in the third column, or in the fourth column, where there are two values given. First of all, we will put these two values to get the value of unknown. Then, taking one by one column, one value will be missing, we have to find the other one. So here value of x is given, y is missing. In the next, x is missing, y is given. Next column, x is given, y is missing. So one by one we can complete the table like this, putting the values in the table, which is the required one. So thank you so much. That is the end of today's lesson. Allah Hafiz.